All right, so I don't even know how you say that. Mount Bierstadt Trail is a popular 6.8 mile out and back trail in Silver Plume, Colorado. It is one of Colorado's iconic 14ers with a peak at 14,066 feet. The table below gives the elevation of a hiker climbing, however you say it, at selected times of the trip. Time is given in hours and elevation is given in feet. So I saw everybody had a really good graph. It's fine. Something like that. All right, and then can the hiker's elevation be considered a function? So for something to be considered a function, each input has exactly one output. So you can only be at one elevation at a certain time, right? You can't be at two places at once. So we would say yes. Do you guys remember how you look at a graph and tell if it's a function? It's a certain kind of line test. Do y'all remember? Vertical line test. So you can also say that it passes the vertical line test. Or you could say there's only one elevation for each time, however you want to word it. All right, and then number 3 says to explain why each elevation except the summit, so except for the very highest peak, is reached at least twice on the hiker's journey. So like we're at this height, and we're at 2 times. So the hiker reaches the height going up, and then they reach the height going back down, or the elevation, I should say. So each elevation will be reached on the way up and down. All right, suppose we wanted to find the inverse, to figure out the time at which the hiker reached a certain elevation. Identify the input and output of the inverse. So the input and output of the original function is this. So for the inverse function, those have to switch. The same thing as like switching x and y. So on the inverse function, the input is going to be the elevation. And the output is going to be the time. So you know, like you want to know what time they were at, whatever, 13,500 feet. You could put that into the inverse function and it would give you the time. All right, now this confused some people in my last class. So this person, these people, whoever, they don't hike to start the hike. So you like ride in a car to start the hike. So estimate the time at which the hiker was at elevation 10,500 feet, or explain why that's not possible. So during this hike, were they ever at 10,500 feet? No. And that's because the hike starts at 10,000, no. Starts at 11,629 feet. Right, and then C asks us to explain how you can use the graph to estimate at what time the hiker was halfway up the mountain, which is 12,978 feet. So what I would do is just draw like a horizontal line at about 13,000. So that's very, very close. All right, and then wherever those intersect, that's going to be your times. All right, so to explain that, you would sketch a horizontal line at 12,978 feet and estimate the times where the graphs intersect. And then number 5 asks, all you guys can cut up. Number 5 asks, is the inverse relation a function? So we talked about thinking about the inverse, and you would put in an elevation, and what you would get out would be a time. If it's a function, you put one thing in and you get one thing out. So if you put in an elevation, is there only one time they're at that elevation or 2? Yeah. So this would be no. The elevations are reached at least twice. We don't have to say at. Okay, have you guys ever heard of the horizontal line test? Probably in Algebra 2, yeah. So for the inverse function to be a function, for the inverse to be a function, it's going to have to pass the vertical line test and the horizontal line test. So the vertical line test tests to see if it's a function. The horizontal line test tests to see if the inverse is a function. And all types of functions whose inverse is a function have a special name, and they are one-to-one functions. And you learned about this in Algebra 2, but I don't think they gave you that title. I don't think like the definition of what that function is called is something that's in the standards of Algebra 2. But it's okay, it's just a word, one-to-one function. And it's a function in which the x's and y's don't repeat. So there's one y for each x, because that's the way it has to be for a function, but there's also one x for each y, so there's no repeating. Right? And some, I guess, characteristics about one-to-one functions. One-to-one function passes the vertical and horizontal line tests. In order for f of x to have an inverse, that is a function f of x must be one-to-one. And the last thing is that the domain of f of x is the range of f inverse of x. And that's because you switch x and y. When you switch x and y, you're switching the domain and range. So also, the range of f of x is the domain of f inverse of x. And that's, like I said, just because you're switching x and y, you're switching domain and range. Alright, so today we're not really going to find any inverses, but we are going to find the domain and range of inverses. And we're going to determine if the function is 1 to 1. So for number 1, the function h of t gives the temperature of a town in Fahrenheit t days into the calendar year. Is h of t a 1 to 1 function, and how do you know? So for it to be 1 to 1, there has to be one temperature for each day, but there also has to be only one day that has each of those temperatures. Is that going to happen? Is there only going to be one day that's 80 degrees? No. So we're going to say no, it's not 1 to 1. Multiple days can have the same temperature. I'm not sure what I was writing. Okay, and number 2 is asking us a lot of things. So the first thing we're going to do is, without a calculator, we're going to sketch the graph of f of x equals the quantity x minus 3 quantity squared. So it's going to be a little parabola. That minus 3 on the inside, how is it going to shift? Subtracting on the inside goes to the right, right? Okay, so we're going to go 3 to the right. And then we're just going to draw a little parabola there. Right? And the second part says, is the inverse of f a function? Would f pass the horizontal line test? Horizontal line test? No. Right, it tells us to support our answer with the information from the graph. So, because f does not pass the horizontal line test. So asking, is the inverse of f a function, is the same thing as asking, is f 1 to 1? Alright, and then if not, which is not, how can you restrict the domain of f so that inverse is a function? So can we cut off part of this graph so it is 1 to 1, where it would pass? We could. So right down the middle of this graph is when x is 3. So if we just, I think I drew this so I could just erase half of it. Yeah. So if I just cut off half of it, then it does pass the horizontal line test. It's 1 to 1. So we could restrict the domain to, so with the amount of the graph that I have left, what is the smallest x value where I have something graph 3? And then it's going to keep going on forever to the right, which is to infinity. All right, and I'm fairly confident that you all did that in Algebra 2. You restricted the domain so you could have an inverse. You may or may not remember that. It's okay. All right, and then on 3 and 4, we have the function, and we're going to tell the domain and range of the inverse, but we are not going to actually find the inverse. So I'm going to do a little graph of number 3. So a square root graph looks like this, kind of like a half of a parabola on its side. What is that minus 4 going to do? How's it going to shift it? To the right 4. All right, so this is what that graph is going to look like. All right, so when I do these, I go ahead and I find the domain and range of the original function. So for f, what is the smallest number in the domain? 4. And it goes forever to the right, which is infinity. What about the smallest y, where you have something graphed? 0. And it's going to keep going up forever to infinity. Okay, that is not the answer to the question, but we're close. So we want to find the domain and range of the inverse. But it's super easy. Like, we've done the hard stuff. So all we have to do is just switch. And that's it. All right, and then this last one is a rational function. This is the graph of g of x. And you all don't have a lot of experience graphing rational functions, but that's okay. We'll do a lot more with them later. But this one has a vertical asymptote, which means this graph is never going to get to that value, which is -1. It's just going to be missing. And so for your domain, it's just that x does not equal -1. What do you guys think the range is? What does y not equal? What y value is there an asymptote at? The asymptote is this dashed line that the graph is approaching as you go out. But it doesn't ever quite get there. So y is never going to equal -3. All right, now we need the domain and range of the inverse. So again, we're just going to switch these. But for our domain, we're not going to say y doesn't equal -3. What are we going to say doesn't equal -3 if it's the domain x? So make sure you switch it, but it's still x if it's the domain, and it's still y if it's the range. All right, what questions do you guys have on inverse graphs?